Okay, Assalamualaikum warahmatullahi wabarakatuh. A very good day to Dr. F for allowing us to present about chemistry mini talks of aluminum oxide, its properties, production and applications to the group 6. Before we begin, I would like to introduce our team members, which consists from the right, who is Nur Zulaika binti Asmadi, Nurul Aiman Afika binti Nora Zirudin, Nur Afika binti Rosdi, and me, Ridwan bin Ishaq. In these subtopics for the video, we will cover 4 contents about aluminum oxides. Firstly, it is about the general meaning of aluminium, its physical properties and chemical properties. Next, purifying of aluminum oxide, the Bayer process, the conversion of aluminum oxide into aluminium by electrolysis, and the uses and application of aluminium. So, aluminium. Aluminium is a metal that exists in the period 3 of group 13 of the periodic table. It is the third most abundant element in Earth's crust, the most copious and abundant, which is similar to the meaning of abundance metal in our Earth crust. It only exists naturally as compounds and never be found as a pure element such as aluminium metal itself. Therefore, it also has a physical properties such as aluminium has a silver-like metal, slightly bluish tint, as you can see from the aluminium sample from the top right. It also has a melting point of 660 degrees Celsius and a boiling point ranging from 2327 to 2450 degrees Celsius. It also has a density of 2.708 gram per centimeter cubic. It is also ductile and malleable. In other words, it can be shaped and stretched into a wire. Aluminium also has chemical properties, which is when aluminium combined with wet air, it can form aluminum oxide, Al2O3. When we observe it, we can see it has a very thin white coating on the metal. It means that it is act as a protection from further reaction with oxygen, which can form rust that is unusable to our daily life. These methods also are widely applied in our household equipment, especially in cutlery. It is also fairly active, which can react with vast number of hot acids and alkalis. Therefore, it can be considered as amphoteric. Okay, that is for the first part. We will continue to the next part. Thank you very much.
Assalamualaikum warahmatullahi wabarakatuh, and a very good day to Dr. F and my fellow friends. My name is Nur Afika, and today I will explain about purifying of aluminum oxide through the Bayer process. What is Bayer process? The Bayer process is the principal industrial means of refining bauxite to produce aluminum oxide and was developed by Carl Joseph Bayer. Bauxite, the most important ore of aluminium, contains only 30 to 60% aluminum oxide, the rest being a mixture of silica, various iron oxides, and titanium dioxide. The aluminum oxide must be purified before it can be refined to aluminum metal. There are 3 steps in the Bayer process. First, reaction with sodium hydroxide solution. Second, precipitation of aluminum hydroxide. And third, formation of pure aluminum oxide. So this is the overview of what I will explain today, which is about the process which changed bauxite to aluminum oxide. Firstly, what is bauxite? Bauxite is a rock formed from a reddish clay material called laterite soil and is most commonly found in tropical or subtropical regions. So the first step is reaction with sodium hydroxide solution. Bauxite is crushed and then treated with high concentration of sodium hydroxide with temperature 140 to 240 degrees Celsius and pressure 35 atm. Note that high pressure is essential to keep water in sodium hydroxide liquid at temperature above 100 degrees Celsius. The crust in bauxite stay as solids. Other metal oxide not react with the sodium hydroxide solution, therefore remain unaffected. Some of silicon dioxide reacts but went on to form sodium aluminum silicate which precipitated out. Aluminum oxide reached with sodium hydroxide solution to give product sodium tetrahydroxoluminate. Alright, the next step is precipitation of aluminum hydroxide. The previously synthesized sodium tetrahydroxoluminate solution is cooled. The sodium tetrahydroxoluminate is seeded with some previously produced aluminum hydroxide. So, the precipitate of aluminum hydroxide is formed. Lastly, the formation of pure aluminum oxide. Aluminum hydroxide can be turned into aluminum oxide with certain condition, which is heating at about 1100 to 1200 degrees Celsius. So, this will conclude all chemical equations in the Bayer process, started with reaction with sodium hydroxide solution, precipitation of aluminum hydroxide, and formation of pure aluminum oxide. I guess that's all from me, and thank you for your attention.
Hi, Assalamualaikum, and a very good day to Dr. F and my fellow friends. My name is Nura Amalfika binti Nur Azharuddin, and today I will be explaining about the conversion of aluminum oxide into aluminium by the process of electrolysis. So now let's take a look into it. For this subtopic, I will be explaining about two things, which are electrolysis of aluminum oxide and the electrode half reactions. So, for the electrolysis process to occur, we know that electrolysis ions need to pass through the electrolyte. But this electrolysis of aluminum oxide, the aluminum oxide must be made molten for this electrolysis to occur. This is because Al2O3 has a very high melting point, which is over 2000 degrees Celsius. So, instead of melting it, we just made it molten for this process to occur. Now, I'm going to introduce to you what is cryolite. Cryolite is an aluminum compound with a much lower melting point than aluminum oxide, so using this reduces some of the cost in extracting aluminum. So now we are seeing at the setup of the electrolysis, we have steel case at the outside, or also known as steel tank lined with refractory bricks, and then we have carbon lining which acts as the negative cathode, or graphite, it's the same thing, and then we have positive anodes which also made from graphite, and it is a form of carbon. So now, everyone, let's take a look at this short video so that everyone could have the overview of this process. So, as we can see, we know that when the electricity flows here, when the battery is turned on, and then the aluminum from the aluminum oxide, this one, these ions, it forms at the negative cathode, and then it sinks at the bottom. So, this molten aluminum that is produced on the bottom of the electrolytic cell is called the effective cathode. However, this molten aluminum is siphoned out of the cell at intervals, while the fresh aluminum oxide is added at the top. This molten aluminum is also known as effective cathode. Okay, so next, let's take a look at the second video. Okay, as we can see in the video, the oxygen from the aluminum oxide forms at the positive anode right here. And then, the oxygen reacts with the carbon of the graphite. And then, when it reacts with the carbon of the graphite, it forms carbon dioxide and carbon monoxide. This is what happens at the positive anodes of this electrolysis process. And this is the half reaction that occur at the positive anodes. So now let's take a look at the electrode half reactions. So at the negative anode, we know that aluminum is produced there. So the aluminum ions are being reduced by gaining 3 electrons at the cathode. However, this produces aluminum at the negative cathode as end product. Next, we are going to see the reaction on positive anode. So on positive anode, oxygen gas is produced. With the cell temperature, the carbon anode will be burned by oxygen, producing carbon dioxide and also carbon monoxide. However, anode must be regularly replaced, which is a major expense, like we saw in the video just now. Here. Okay, as you can see, the carbon anode is being burned by oxygen, which then produces carbon dioxide and carbon monoxide. So therefore, the anode must be regularly replaced, which is a major expense. So that's all for me. I hope you enjoy learning about this electrolysis process of aluminum oxide. Thank you.
Hello and Assalamualaikum. My name is Nurzulika binti Asmadi, and from my turn, I'll explain about uses and applications of aluminum oxide. Right now, I want to let all of you know that there was a lot of uses and applications of aluminum, such as in military, electronic industry, industrial applications, and medical industry. So, how aluminum is used in military and protective equipment? Aluminum oxide strength and lightweight qualities contribute to enhancing body armors, like breastplates. If you don't know what breastplates are, you can take a look at the picture next to the box. As well as vehicle and aircraft armor, which is its biggest market of applications of aluminum oxide. Then, as you can see at point C, aluminum oxide is also used in synthetic sapphire bulletproof windows and ballistics. So, in next slide, we are going to talk about how aluminum is used in electronic industry. As we all know that aluminum have high melting and boiling points and have an excellent thermoresistive properties that makes aluminum oxide desirable in the manufacture of high temperature furnace installations and electrical insulators. At point B, you can see the pictures of spark plug insulators that use the application of aluminum oxide. So if we observe at the point C, we can conclude that microchip industry also use the application of the aluminum oxide, as alumina film are also vital components in the microchip industry. And for this slide, I will explain about uses and applications of aluminum in industrial application. To explain point A, we can say that aluminum component that we call alumina is chemically inert and can be used as a fillet in plastics, bricks, and other heavy clay like kilns. In point B, you can see the pictures of sandpapers, as aluminum is often used as an abrasive for sandpaper due to its extreme strength and hardness. For point C, we can see that aluminum oxide are also used for the production of piping components. If we look at the pictures, we are familiar with it. There are elbows, teeth, straight pipes, hydrocyclones, reducers, nozzle, and valves. And this is the final slide that we are going to talk about the uses and the applications of aluminum oxide in medical industry. Aluminum oxide is the preferred material for bearings in hip replacement, bionic implants, prosthetic eye substitutes, tissue reinforcement, dental crowns, abutments, bridge, and other dental implants due to its hardness, bioinertness, and chemical properties. As you can see, the picture next to the box is a picture of the hip replacement. Aluminum oxide is also used in lab equipment and tools like crucibles and furnaces. The picture next to the box is the crucibles. Okay, I think that's all for me, and thank you for paying your attention for me and listening. Thank you.